So if you look at the greenhouse gas emissions that are, currently choking our planet, you probably picture a massive factory smokestack, right? Or a congested highway full of traffic, or maybe like an oil rig.
Yeah, that's the standard mental image for most people.
Right. But you are actually missing the real culprit. Look at the phone in your hand. Look at the chair you're sitting on. Or the coffee mug on your desk. Almost half of all U.S. greenhouse gas emissions don't come directly from the energy sector or transportation in isolation.
They really don't.
According to official data, a staggering 42% of total U.S. greenhouse gas emissions come entirely from the invisible life cycle of our stuff. Just the physical materials we buy, use, and throw away.
It is a massive blind spot for almost everyone.
Yeah.
I mean, we interact with the physical world constantly, obviously, yet the journey of those physical objects is entirely hidden from us.
Completely hidden.
And today's deep dive is designed to change that. We're pulling apart a highly detailed official guide from the U.S. Environmental Protection Agency, the EPA. It focuses on a framework they call Sustainable Materials Management, or SMM. Our mission today is to completely upend how you think about the physical material in your life.
We're tracing it all the way back.
Exactly. Tracing its path from the moment a raw material is violently extracted from the earth to the moment it is discarded.
Okay, let's unpack this. Because to even understand why the EPA is pushing this new framework, we have to understand the core tension of the document.
Yeah, the underlying problem.
Right. It is essentially a massive society-level math problem. For decades, we've operated on this really dangerous equation. It's basically the idea that to achieve economic growth, we must relentlessly increase our resource consumption.
And the historical context provided in the text illustrates just how volatile that equation has become. We're looking at the sheer mathematics of consumption here.
Yeah, the numbers are wild.
They are. Throughout the 20th century, global raw material use didn't just tick up alongside population growth.
Yeah.
According to data cited from a G7 leaders' declaration in the text, global raw material use rose at roughly twice the rate of population growth.
Twice the rate. Meaning it wasn't just that there were, more humans needing basic necessities.
Right.
It means every individual person was consuming drastically more physical material than the generation before them.
Exponentially more.
And the document actually quantifies this relationship between wealth and materials. It notes that historically, for every 1% increase in gross domestic product, our GDP raw material use rises by 0.4%.
And that 0.4% might sound small, right?
Yeah, that sounds like a tiny fraction.
But when compounded globally, it demands a massive, massive physical toll from the planet just to keep the economy functioning.
I was actually trying to wrap my head around that specific ratio because it's a terrifying mechanism when you visualize it.
Oh, absolutely.
Think of it like an enforced diet where every time you get a 1% raise at work, you are physically forced to eat 40% more food.
That is a very visceral way to look at it.
Right. Like, eventually, no matter how rich you are, the system is going to burst. You just physically can't sustain that intake.
That analogy perfectly captures the structural flaw, honestly. The planet is the body in that scenario, or, the structural boundary.
Exactly.
If we connect this to the bigger picture, the resources simply aren't expanding, but the economic demand for them is skyrocketing.
Because everyone wants that GDP growth.
Right. As global populations and economies continue to grow, the competition for finite resources is only going to intensify. The extraction, the manufacturing, the transportation, and the eventual disposal of these materials, that is what drives that 42% of U.S. greenhouse gas emissions we talked about.
It's all connected.
The whole system is under unprecedented strain. Well, it's propped up by a lot of hidden inefficiencies.
There has to be a tangible way to see this inefficiency in our daily lives, though. And I want to look at a highly specific, everyday example from the text. Food waste.
Oh, yeah. That's a huge one.
When you throw away like a rotting apple from the back of your fridge, you probably just feel a brief pang of guilt for wasting 50 cents, right? You toss it in the trash and move on.
Right, because that is the financial cost of the immediate item. But that's just a symptom of a much larger invisible hemorrhage.
Hemorrhage is a good word for it.
The text challenges us to look at the hidden life cycle of that single apple. When you throw it away, you are not just throwing away fruit.
No, you are throwing away the land that grew it. You are throwing away the water that irrigated it.
Exactly.
Yeah.
You also have to factor in the synthetic fertilizers and pesticides applied to the orchard. Producing those chemicals requires a massive amount of fossil fuels.
Just to make the chemicals.
Just to make them. Then there is the diesel burned by the tractor to harvest the apple, the electricity used by the refrigerated warehouse to store it, the fuel for the truck that drove it to your grocery store.
And the electricity your own fridge used to keep it cold before you threw it in the trash anyway.
Precisely.
And then the diesel truck comes to pick up the trash and dump it in a landfill where the apple rots and releases methane. The sheer causality of it is just mind-blowing.
It really is. Now, multiply that single apple across the entire United States.
Oh, boy.
The EPA document lays out the aggregate data for what U.S. food loss and waste actually represents in terms of hidden resources. Annually, we are wasting 140 million acres of agricultural land.
Wait, 140 million acres just dedicated to growing food that goes directly into the garbage?
Directly into the garbage. And furthermore, we are throwing away 5.9 trillion gallons of blue water.
Okay, wait, I have to pause you there. Blue water, as opposed to what does that term actually mean?
Right, so it is a crucial distinction in materials management. Green water refers to natural rainfall that just naturally soaks into the soil.
Okay, so just rain.
Yeah. Blue water, on the other hand, refers to fresh surface and groundwater. It's the water we actively pump out of lakes, rivers, and deep underground aquifers for irrigation.
So it's water we have to exert energy to move.
Exactly. When we waste 5.9 trillion gallons of blue water, we are actively draining our finite freshwater reserves for food that is never even consumed.
So we are literally draining the aquifers for nothing. And what about the chemicals used on those 140 million acres?
The data shows we are wasting 778 million pounds of pesticides and 14 billion pounds of fertilizer annually.
Billions of pounds of fertilizer. We are fundamentally altering the chemical makeup of our soil and creating toxic runoff in our rivers just to grow garbage.
Just to grow garbage. And the mechanical effort required to sustain this wasted supply chain results in burning 664 billion kilowatt hours of energy.
I can't even picture that amount of energy.
It's massive. Ultimately, this specific segment of waste releases 170 million metric tons of carbon dioxide equivalent greenhouse gases into the atmosphere.
Hearing those numbers, it completely shifts how you view your own kitchen. I look at a piece of bread I'm about to throw away, and suddenly I see the tractor exhaust, the depleted aquifers, the chemical runoff.
It lifts the veil, doesn't it?
It makes you realize how entirely blind we are to the reality of the physical world.
And the planetary consequences are severe. The text makes a direct connection between this invisible, inefficient consumption and irreversible environmental damage.
But what kind of damage specifically?
Well, this scale of waste drives massive habitat destruction. It causes biodiversity loss because we are continuously clearing wild land and applying toxic chemicals for absolutely no reason.
Since the food just rots anyway?
Exactly. It contributes heavily to overly stressed fisheries, and it accelerates desertification.
That's when land just turns to sand, basically.
Yeah, it's the process of turning fertile, life-sustaining land into barren desert.
So what does this all mean? We know the math doesn't work. We know we are, burning through the chassis of the car, going back to that analogy.
Right.
What is the EPA's actual framework to plug these massive holes in our system?
The framework they advocate for is sustainable materials management. The foundation of SMM requires us to adopt a comprehensive life cycle perspective.
Okay, so if we aren't just looking at the trash can at the end of the line, where does this cycle actually begin? How does the EPA map this out?
They break it down into a continuous chain. It starts with raw material acquisition, so the physical mining, harvesting, or drilling.
Digging it out of the dirt.
Digging it out of the dirt. Then it moves to materials manufacture, where those raw elements are processed into usable materials like steel or plastic. Next is product manufacture, where the final item is actually assembled.
Okay, got it.
Then comes the use, reuse, and maintenance phase. And finally, there's end-of-life management, which historically just meant tossing it in a landfill. SMM is a systematic approach to looking at that entire chain holistically.
But what are they actually trying to achieve by looking at the whole chain? Because mapping it out is one thing, fixing it is another.
The goals are to use materials in the most productive way possible, with a primary emphasis on simply using less material overall.
Just shrinking the footprint from step one.
Yes. SMM aims to reduce toxic chemicals and environmental impacts throughout every single stage, not just at the end. Ultimately, it is about ensuring we have sufficient resources to meet today's needs, while preserving enough for future generations to meet theirs.
But wait, hold on. This sounds incredibly logical on paper, but it completely breaks the traditional business model of modern capitalism.
How so?
Well, the old model is extract cheap materials, manufacture a product, sell it, and completely forget about it. The manufacturer wants you to buy the phone, and when it breaks in 2 years, they want you to throw it away and buy a new one.
Planned obsolescence, basically.
Right. But the text suggests companies should want to maintain relationships and eventually take these products back. Why on earth would a company willingly take their trash back?
What's fascinating here is how the text explains the shifting economics of global resources. In the past, raw materials were incredibly cheap and easy to extract.
You could just scoop them up.
Exactly. But today, ore grades are dropping, meaning you have to mine drastically more earth to get the same amount of copper or lithium. It is becoming terribly expensive.
Oh, I see where this is going.
Under an SMM framework, a used product isn't trash. It is a highly concentrated, pre-processed gold mine of valuable materials.
So the idea is that the manufacturer doesn't just sell you an item and disappear. They maintain a relationship to ensure the product lasts. And crucially, they want it returned at the end of its life because it's literally cheaper to mine an old phone than to mine a mountain.
Precisely. In a world of intensifying competition for finite resources, taking products back reduces a manufacturer's material supply risk.
Because they have their own stockpile.
Exactly. If you control the end of life of your products, you essentially become your own supplier. You are insulated from global shortages of rare earth metals if you are systematically reclaiming them from the products your customers return to you.
That is brilliant, actually.
And the text notes this also helps manufacturers identify changing customer needs and creates incredibly deep customer loyalty.
So you are closing the loop. You are turning a one-way street to the landfill into a continuous circle.
A true circular economy.
But to make that work, the physical products have to be fundamentally different from the start, don't they? Right now, if I try to take apart my laptop or my blender, I'm going to destroy it. The components are super glued and soldered together.
They are, and that brings us to how companies actually execute this on the factory floor. SMM relies heavily on a concept called design for disassembly.
Design for disassembly. It makes me think of the difference between building a model airplane with super glue versus building it with Legos.
Oh, that's a great way to put it.
Right. If you build a model airplane with super glue, it is permanently bonded. It's one rigid object forever. When you are done playing with it, you can't harvest the wings or the cockpit for anything else. You just throw the entire solid chunk into the trash.
Because you can't break it down cleanly.
Exactly. But if you build that airplane with Legos, it might be an airplane today, but when you are done, you can easily snap it apart. You can use those exact same pieces to build a car, a house, or a spaceship.
That is exactly the shift required. We currently live in a superglue economy. Materials are permanently fused together in ways that make them economically impossible to separate and recycle.
Which is why recycling is so broken right now.
Exactly. SMM demands a Lego economy. And to figure out how to design these Lego products, companies use a highly rigorous analytical tool that the text calls life cycle assessment, or LCA.
Life cycle assessment. How does that actually work in practice? Because it sounds like corporate jargon. How does an engineer actually use LCA?
Let's apply it to a relatable, everyday debate. Imagine a company trying to decide whether to sell their coffee in a disposable paper cup or a styrofoam cup.
Okay. Most people intuitively assume the paper cup is better for the environment simply because paper eventually biodegrades and styrofoam sits in a landfill forever.
Right. Paper seems like the obvious, environmentally friendly choice.
Right.
But if that company runs a life cycle assessment, the math forces them to look at the invisible trade-offs. The LCA evaluates the specific air, water, land, and energy consequences across the entire life cycle.
Not just the landfill part.
Exactly. It might reveal that the paper cup required cutting down a tree, transporting heavy logs, using massive amounts of blue water to pulp the wood, and applying highly toxic chemicals to bleach the paper white.
Wow, and the styrofoam.
The styrofoam cup, conversely, might use a fraction of the energy and water to manufacture.
Oh, wow. So LCA is the math that forces us to weigh those hidden upstream costs against the downstream problem of the landfill. It stops you from just making an assumption based on the final stage of the product.
Exactly. LCA evaluates the total human health and environmental impacts of possible alternatives. If they are deciding between a specific plastic or a metal casing for a product, They aren't just looking at which raw material is cheaper on the global market today.
They're looking at the whole picture.
They use LCA to ask which one requires more blue water, which one releases more greenhouse gases during transport, which one can actually be successfully snapped apart and reused like a Lego brick.
It is a completely different set of accounting principles. And reading through the document, it becomes clear that the EPA isn't framing this solely as an environmental crusade to save the trees.
Not at all. The text explicitly frames sustainable materials management as an economic imperative. A more productive and less impactful use of materials is how a society remains economically competitive.
It's a survival strategy for businesses.
It really is. In a resource-constrained future, the societies and businesses that figure out how to do more with less and how to endlessly cycle their materials, they're the ones that will thrive.
While everyone else runs out of stuff.
Exactly. The ones stuck in the superglue economy will face massive supply chain disruptions and skyrocketing raw material costs. SMM secures supply chains and drives long-term profitability.
Which really brings everything full circle back to you, the listener. Every single physical item you interact with today has a massive invisible life cycle attached to it.
Every single one.
The clothes you are wearing, the device you are listening on, they all have a history of extraction, massive blue water usage, and manufacturing. And they all have a future of either permanent waste or deliberate reuse.
It's the choice we're facing.
Recognizing that hidden life cycle is the first step to cutting through the noise and making smarter choices. You start to see the immense hidden cost of the superglue economy, and you start to demand the Lego economy.
And, if we take this SMM framework to its logical conclusion, it raises a truly profound question about the future of our daily lives.
Oh, what's what?
Well, the text heavily emphasizes manufacturers maintaining relationships for the maintenance and return of their products, right?
Right, to get their materials back.
If manufacturers truly take responsibility for the entire life cycle of their materials, and they absolutely need those materials back to survive economically, will we eventually see a future where you don't actually own any of your physical goods anymore?
Wait, what do you mean? Like not owning my own stuff?
What if, instead of buying a washing machine or a laptop, you simply subscribe to the materials?
Oh, wow.
You use the product for its functional lifespan, and then it is inevitably returned to the manufacturer to be disassembled, upgraded, and reborn.
A completely subscription-based physical world where the concept of throwing something away literally doesn't exist anymore because you never owned the raw materials to begin with.
Exactly. You just leased the shapes they were in at the time.
That is absolutely something to chew on the next time you look at the mundane stuff sitting on your desk. Thank you so much for joining us on today's deep dive into the hidden life of our materials. Keep looking closer at the world around you, keep questioning the systems we take for granted, and we will see you next time.